A very good morning to our panel of judges, Inch Aminur Rashid bin Nurdin and Inch Sharuddin bin Zakaria. So, I am Thamishchandran, son of Ganesan, and my supervisor is TS Dr. Sahadati binti Muhammad Rosali. So, today I would like to present about my PSM1 project, which is development of carbon monoxide detector using IoT technology. Okay, the introduction. Carbon monoxide is a colorless, tasteless, and toxic gas to humans. It is usually the result of unhealthy combustion and it is great threat to the human health. The CO has made many intoxication victims in the world in recent years. Therefore, researchers investigated many materials using several methods and techniques to detect this gas and to commercialize them in the form of CO sensors. What is the background of this project? Commercial instruments for detecting the presence of carbon monoxide are one of the present solutions. This device prevents the danger of carbon monoxide intoxication by some alarm. These solutions are not 100% works in current technology. The Internet of Things, which is IoT, is a new technology paradigm that involves a worldwide network of machines and objects that can communicate with one another. The Internet of Things is widely regarded as one of the most crucial areas of future technology, and it is receiving increasing interest from a variety of business. When linked devices can interact with each other via IP communication, the true benefit of IoT for businesses may be completely realized. So simply what I'm trying to say here is the presence carbon monoxide detectors is majority only can detect the carbon monoxide gas and give a sound by using a buzzer or an alarm. The problem statement. Sudden death cases while sleeping in car is raised among Malaysians. The exhaust gas leakage has contaminated the car passenger compartment, especially for cars that has been not well maintained. The carbon monoxide gas leakage are hardly traced by drivers. Absence of an additional tool to detect the presence of carbon monoxide gas is a big issue and its application is seen as unimportant. Okay, the objective of this proposed project is to develop a portable system that can detect the presence of carbon monoxide gas leakage in car, to monitor the concentration of carbon monoxide gas using IoT system, to analyze the concentration of carbon monoxide gas at different timestamps in different environment and place. The scope of project is to specify the features and components that is used to complete the system. First, microcontroller named Raspberry Pi is used as the brain to control all the components will be used in this project. The carbon monoxide detection system can detect the presence of the gas by using carbon monoxide detection sensor, which is MQ7 sensor. An LCD screen will be used to display the standby mode of the system. A real-time concentration can be monitored in smartphone using the IP address that will be created by MQTT portal. A buzzer will alert the driver about the presence of carbon monoxide gas. This device is useful to detect the presence of carbon monoxide gas. Yes. In a nutshell, this project is only to dedicated for vehicle mainly in car to avoid sudden death of humans. For literature review part, I am choosing three main research paper before. This chapter discusses about each item in the project and about the system that has been made already before. Based on the knowledge gained from the reviews, most of the proposed work has been included with IoT system and it also has some advantages and disadvantages. So it is focused on achieving more precise measurement and correct alerting system to prevent user from exposed to carbon monoxide gas. By using the right technology techniques, the performance of the carbon monoxide detector can be optimized. Okay, first is Junior Stel Rajagopal. The title of this project is Emission Gas Detector for detecting vehicle exhaust based on combined gas sensor. He proposed the work with combined gas sensor, microcontroller Arduino, and Bluetooth. Emmanuel Estrada uses low-cost CO detector integrated with IoT. The equipment or technique used is MQ7, ESP32, and Blink application. Elias Masek proposed a carbon monoxide gas leakage detection system prototype and he used Node MCU, JSON module, and social media as its his proposed work. Okay, methodology part. From here, we can see the system is start when we on the system. Raspberry Pi initialization. The Raspberry Pi will run in the background to collect the data of the carbon monoxide level. So, get CO levels, store the data, and send via MQTT. Okay, every data that collected by Raspberry Pi, we can access the data via MQTT portal. Okay, so when the CO gas is leakage, if yes means this in the LCD display it will show CO gas leakage. At the same time the buzzer will on. At the same time it will send SMS and location via GSM and GPS modem to the registered user number. If the CO is not leakage, there is no any leakage, the system will begin from here as usual, the Raspberry Pi initialization where the Raspberry Pi will collect the data of the CO gas. So after the user receives the SMS, whether the user, we don't know whether the user is alert or not. So if the user alert means he should on and off the system. So when we on and off the system, it will start again from overall. If the user is not alert means the system will again display the CO leakage, the buzzer will still on and it will send again the SMS to the registered mobile number. This is how the system works. Okay, this is a simple block diagram of the project. Okay, Raspberry Pi is the heart of this project. So, which is MQ7 sensor. When MQ7 sensor detects the carbon monoxide gas, it will store the data to MQ Raspberry Pi. So it will stay, we can see the data in MQTT portal. At the same time, when the CO is detected, it will alert the user by using a buzzer. An LCD display will show the gas is detected, and there will be a GSM and GPS model will send the data to the registered mobile number. Okay, this one is the initial result for MQ7 gas sensor testing. So as you can see here, this is MQ7 gas. I'm using an Arduino and there is a CO detector LCD display and a buzzer. So I can explain more in the video next. Okay, this one is the GPS modem testing via GSM module. Okay. Okay, now we are moving on to the simulation process. So this one is the testing for MQ7 carbon monoxide gas sensor. Okay, this is the coding for the MQ7 gas sensor. As you can see here, this is the coding. Okay, so this one is the MQ7 gas sensor. This one is the Arduino, LCD display, buzzer and an NPN transistor. Okay, so here when I start the simulation, in the LCD display it will show CO Detector, means the name of the system. After I press the logic toggle, which means it assumes that carbon monoxide is leakage. So the LCD display will show carbon monoxide detected. At the same time, the buzzer will on. Okay, now I run the simulation. Okay, so you can see here when I press the start button, it shows CO Detector, means name of the system. Okay, now I'm pressing the logic toggle. Okay, as you can see here, it shows CO detected and the buzzer it start to on. So again, CO detected and the buzzer it start to on. That's all. This one is the second simulation for the GSM and GPS module. Okay, so as the carbon monoxide sensor detects the presence of carbon monoxide gas, it will send the information to the registered mobile number via GSM module of the location, which is latitude and longitude of the location where the system is detect the carbon monoxide gas. So here I'm using a Arduino Uno and then MQ7 gas sensor. This one is the GSM module and this one is the GPS module. So this one is the virtual thermometer, so that we can see the latitude and the longitude of the location. Okay, so I'm running the simulation now. Okay, so when I press the logic toggle here, you can see in the virtual thermometer, okay, it will shows that it will send a message to my number. This one is my registered number and this one is the location, which is latitude and longitude of the location where the carbon monoxide gas detected. Okay, that's how I do the initial result for my project. Thank you. Okay, this is the BDP1 gun chart. So by refer to this method, I am completely successfully complete my BDP1 thesis report. Okay, this one is my expected planning for BDP2. So according to this, by week 13, week 14 and 13, I will complete my project and my thesis report. Okay, as the conclusion, carbon monoxide is still the leading cause of death from poisoning in the world. The design and construction of IoT-based carbon monoxide detection system will help the user to identify the toxic gases. Okay, I hope the panel and the judges understand my presentation and hope will give the feedback for me to improve in the BDP too. Now for the Q&A section. Thank you very much.